All right, we're going to talk about surface area of solids in pre-algebra today. So remember a couple of things. We're going to use these. We know how to find the area of rectangles and triangles, hopefully at this point. If not, hey, this is how we do it. For both of these, we're going to use the terms base and height. You could use the words length and width, especially for rectangles or squares, but we use base and height for both rectangles and triangles so that it's consistent. It doesn't actually matter which side you call base and height. The important thing with base and height is that they usually surround a right angle. So for rectangles, that's easy because we have 4 right angles. So we could have this be the base, or we could have this be the base, but whichever one is base, the other side is height. So like if you pick the bottom as the base, then technically the top is also the base because those are the same length, right? And then we've got our other 2 sides this way. So basically you're multiplying those 2 sides together, and that gives you area. For a triangle, it's an added step of timesing by a half, or if you would prefer to think of it this way, you do base times height and then divide by 2, whichever is easier for you. For triangles, the fact that it's base and height sometimes means they have to give us extra information, not just the sides of the triangle. We really just need one side of the triangle, so that this would maybe be our base down here, and then our height has to come out from the base. So this extra line we have drawn, that's our height in this case. So hopefully you remember how to find area for things like squares, rectangles, triangles, but we will be exploring that some, so it's not too big a deal if you need a refresher. Okay, so we're going to look at types of solids, and to do that I'm actually going to cut away and we're going to look at some geometric figures, and it's going to be a fun time. Alright, so surface area has to do with finding the area of each side of a 3-dimensional shape and adding it together. That's different than volume. You might be familiar with volume and surface area of one, both, neither, but those are measuring 2 different things. When we have a 3-dimensional shape, right, which is a shape that like we actually hold in our hand instead of a shape that we just draw on a piece of paper. We have a 3-dimensional figure. There are 2 main things that we kind of think about with figures. One is surface area and one is volume. Volume talks about how much space this is taking up. Okay, so if I were to pour something into this, like sand or water or whatever, the amount that fills it up, that has to do with volume. But surface area is a measurement that kind of measures the outside of this. And so those are used different places. Like surface area might be used if we were to paint something. And it could be that we're painting a shape like a box or something like that. Or it could even be that you're painting a room in your house. You would want the area, if you want to only make one trip to the store for paint and hope for the best, you'd want the area of the walls that you're painting this, and then you'd be able to look at how much can is in a paint of can, and try to figure out how many cans of paint you would need. I don't know why I just struggled so much to say that, but here we go. So these are some of the shapes that we're gonna see in this section, or similar ones. We got kind of 3 sections actually, I guess, of things that we have for 3-dimensional shapes. And so one of the things, and we're not going to do this in this section, so I'll just bring it up real quick, is when we have things with a circular base, those are going to be a little bit different than when we don't have circles involved at all. So circular base, like top and bottom, this would be a cylinder, kind of like a can, and then of course we have circular base, but then it comes up to a point, that would be a cone. Now we're not going to have to deal with those today, probably will at a later point in time. So the other 2 kind of sections we have prisms and we have pyramids. So these 4 are prisms. A prism happens when you have the same shape on the top and the bottom, and then to connect those we have rectangles around. Or they could be squares depending kind of on the size of them, right? But what that means is, if I can get this back out. Okay, phew. So what that means, so this is actually going to fold out and show us what this looks like as what's called a net, whenever, so N-E-T, not like the name Annette. So I take this out and this is a special figure that shows me actually what it would look like. And what we can do is we can actually think about the different shapes that are happening. We can see, right, this was the top and bottom, and these two shapes are both squares that look like they're the same size. Then we have 1, 2, 3, 4 rectangles that was making up the sides around this way. And so that kind of helps us see, okay, what are the different shapes that we would need to find the surface area? Because the surface area means take all the sides, find the area of them, and add them together. Whenever we have prisms like these, we should end up with this kind of consistent thing of the top and bottom should be the same depending on how you have it, oriented. And then we should have rectangles around it that are the same. So keep that in mind. This is not one we're going to have to find, but I wanted to point out because of just how we name them. This would be a hexagonal prism because it's a hexagon. We've got a hexagon on top and bottom, but these are each rectangles around. And so the way this works is there'd be 6 rectangles around because a hexagon has 6 sides. So I thought that was cool. I wanted to show it to you, but we're not going to have to find the surface area of hexagonal prisms, thankfully. I don't actually know off the top of my head how to find the area of a hexagon. I'm sure it would have to do with pretending that it's made up of triangles or something. So this is actually a cube because all of the sides, all of the edges, that's another word we use, is the lines that kind of make up. It's hard to define it without using edges. Like the edges of your shape are called edges. We've got corners. Another word for corners is vertices. The actual sides of our shape are called faces. So those are some more words that might be helpful to know. So all the edges are the same, and if we look, each of these squares looks like they are the same. So if we know that it's an actual cube, so all the sides are the same, or all the edges are the same length, then it's actually even easier to find surface area because we're just finding the area of one thing and then saying, how many of these squares do we have? Which we would be able to count them or visualize them. There should be 6 of them. So that's a couple prisms. We could have a triangular prism, so a triangle on top and bottom. Well, what's that gonna look like if we unfold it and think about area? Well, we would have a triangle on top and bottom, and then we have these 3 rectangles that may or may not be the same size actually. This also is true for has a square base on this prism, but if it was a rectangular base, then we'd have more things to find. What I mean by that is, like, these do not all 3 have to be the same square, because this right here, this triangle looks equilateral, and so that's why these look like they're the same size. But that's not always the case. If this was like taller than it was wide, that would affect the dimensions of these rectangles. So we're going to have to basically kind of visualize or come up with a way to really like understand what it is we're trying to find with these shapes. And then we've got pyramids. So the difference in a prism and a pyramid is a pyramid just has one base. One of these is a square, one of these is a triangle. You technically could have any type of base you wanted, but these are the only 2 I have access to right now. But instead of there being 2 of that shape, there's just 1, and then you have triangles coming up to a point. So I think it's neat to see these flattened out because they kind of look like different kinds of stars, I guess. So this would have 4 triangles, and this has a square base. You could have a rectangular base, and that would change it up a little bit. But being able to visualize what the pieces of this are so you can find the surface area is really helpful. So there's that. And then triangular pyramid, I think these are the hardest to draw on 2-dimensional paper in a way that actually shows that they look like a triangular pyramid. And essentially what would happen here is that we have a triangle for our base, and then we have triangles coming up to make our point. So again, we visualize what's going on so that we can find the area of each, add them together, and get the surface area. Was I right? Was it a fun time? All right, so surface area, right, is the sum of the areas of all of the sides. Units for surface area, because units are something that we in math tend to care about and in science tend to care about especially. The units for it is the same as regular area because we're just taking the different sides, their areas, and adding them together. So if we have inches, for example, our units would end up being square inches, just like they would be for area. So let's actually look at some examples to see how this goes. So example 1 here, find the surface area of the figure. This is a triangular prism. I know that because there's a triangle on top and bottom, and then there's rectangles around the side. Now this is a fairly well-drawn 3D figure, in my opinion. A computer did it, not me, which is why it's well-drawn. So what we do now is we have to think about the different sides that are happening and how to find the area of them. Let's start with the triangle. Also notice, actually, this is important, that this only tells us like that 10 feet is this right here. But that's not the only place that 10 feet would be, right? It would also be right here. So it may be that you have to kind of think about those things to get all of the dimensions you need as you go along. So for this triangle that we have sides of 6 feet, 8 feet, and 10 feet. Well, to find the area of a triangle, we need two sides that are along a right angle. So we actually just need the 6 and the 8. So for this triangle that's on top and bottom, we're going to do 1/2 times 6 times 8. You can either half 6 and then times it by 8, or half 8 and times it by 6. Or you can do 6 times 8 and then divide by 2. Whatever seems easiest to you. Any of those three ways are supposed to end up, well, we should end up with 24, and this would be feet squared. Now, at some point, though, we need to think about the fact that there's not just one of these triangles, there's two. So at some point along the way here, we will times this by 2 and then add it in with the other things. Now let's look at the different rectangles we've got going around. Because we have 3 different sides, like they're different sizes for our triangle, we're actually gonna have 3 different rectangles, right? So like this rectangle right here, ooh, that was a bad looking rectangle. That rectangle has sides of 6 and 8. Okay, so that would be 48 feet squared. But this rectangle has 8 on bottom, but what's the height of this? Well, we're going to use this 8. They didn't give it to us all the way around, but that's fine. Each of these heights would be 8. So this purple rectangle I'm pointing out is 8 times 8. Also, it may not actually look like a rectangle unless you're actually thinking of it in perspective, right? They have to you have to draw things kind of weirdly to make them look three-dimensional when you're drawing on a piece of paper. So this is 64 feet squared. And then finally, we've got a triangle, not triangle, we have a rectangle here in the back that has a base of 10 and a height of 8. So 10 times 8, which is 80. So then we need to add these things together. 24 feet squared times 2, that's 48 feet squared. So we got 48 plus 64 plus 80. So add our ones together. 8 plus 8 is 16, plus 4 is 20, plus 0 is still 20. And then we've got 4 plus 6 is 10. 2 plus 8 is 10, so that's 20. And then we've got another 4, so that's 24. So 240 feet squared. Okay, so we got to make sure that we think about each of the sides. Where we can do shortcuts, we will. So for instance, we've got a cube on the next one. So it's not going to be as much work because if all of these edges are 11, then we basically have how many squares that are the exact same. Well, picture a square in your head, or maybe try to count them on this paper, but you have a top and a bottom, and then you have the sides going around. There's 4 of those sides. So in all, we have 6 sides that are all the same in this case. To get the area of one of these squares, we do 11 times 11, which is 121. So our answer to this is whatever we get from 6 times 121. So you can see how some of these problems may end up being long. Some might be a little bit shorter. Most of them are going to involve math that feels like you're getting big numbers, I think. Don't have to, but just surface area by nature is going to give us bigger numbers than other things we might be doing. I got 726, and this would be yards squared. So there you go. All right, this next one is a rectangular prism because it's got rectangles on top and bottom. So we basically, for a rectangular prism, it's going to be like the opposite sides are the same. So maybe the top and bottom are the same, the left and right are the same, the front and back are the same. And so we only have to find three things. We just need to make sure that we account for the correct three things. So for instance, one of my rectangles I need is 8 and has dimensions 8 and 6. Okay. And then one of them has 4 and 8. If you're doing this, like if you decide to draw like this and you draw and it doesn't have both dimensions, well, look on the other side of the figure to try to see what's missing and where it needs to go, right? Because I could have actually drawn this blue one up here in the front, but it only had 4 listed, so I chose to do the one in the back because it had 4 and 8. Okay, what's our last one? Whoop. We've got top. From my perspective, I've got top, so that's top and bottom. I've got kind of the back, so that's front and back. So now I need the ones this way. My gesturing probably isn't helping since it's mirrored. So my bad. So it looks to me like I need this one. You also, if these are all different dimensions, can use this trick where you should be matching up different numbers together. It won't work if you have a repeated unit like 5, 5, and 8 or something like that. But for the three numbers, 8, 6, and 4, we should have one set that pair 8 and 6, one set pair 4 and 8, and another set pair 4 and 6. That's the way we can group those together. All right, let's take a look. This is 48, 32, and 24. But each of these happen twice. So either we can go ahead and multiply them by 2 now. It kind of depends on how much you like multiplying by 2. Something I find relatively easy to do. But multiplying by 2 at some point, or you could just write them twice if you would rather add. We could add these together and then multiply our answer by 2. Whichever way you want to do it. Let's see. If I do it that way, 8 and 2 is 10, plus 4 is 14. This is 5, and 5 is 10. And we're going to times that by 2 because that's basically half of the surface area that we've accounted for. So 104 times 2 is 208. Let's check out our units. That'd be kilometers squared. Now, those were prisms. What's different about a pyramid? Well, in some ways, nothing's different. It's still that we're looking at the shapes that make up a pyramid and finding the area of them and adding them together. But it's just that pyramids themselves are different. So the more you know about how these shapes kind of work, the easier it might be to actually work through the problems. Because I know since it's a pyramid that I have one thing happening on bottom. This would be a 12 by 12 square. So 12 times 12 is 144. Okay, but then I have these triangles going around. Since the bottom is a square, each of these triangles is the same. And if that wasn't the case, like if this had been 14 or something like that, they would have also had to have given us another height to go with that, just kind of by the way. So we don't have to deal with that though, because if it's a square bottom, all 4 triangles, 1, 2, 3, 4, should end up being the same. So we're going to do 1/2 times, I don't know why I switched back to an X for times, 1/2 times 12 times 10. So that would be 120 divided by 2, which is 60, but that's happening 4 times. So either add it together 4 times or multiply by 4, and we get 240. So we're going to add the base, which is 144, to those sides, which is 240, and get 483, or 384, which is meters squared. Now, this is part of the Math You See curriculum for pre-algebra. This is lesson 15, and they talk about triangular pyramids in the teacher's volume, but I didn't notice any triangular pyramids in the workbook that you have to work out. And I think part of that is it's so hard to draw pyramids in a way that looks good and makes sense. So just keep that in mind, that if it says, like, I think the instructions at one point say, assume it's a square pyramid unless it says otherwise. And so that means that you should assume the base is a square even if you can't tell it's a square. So make sure you're paying attention to instructions like that. But we'll go ahead and find this one here at the end, although it is going to be annoying because we've got decimals, so my bad. So let's see, we've got this triangle on the bottom has a base of 4 and a height of 3.5. Right, so we're going to do 1/2 times 4 times 3.5. That's the bottom. Then we've got 3 triangles around. This is an equilateral triangle on bottom because it points out that this is a 4. And so what that means is that those 3 triangles that are around, those are each going to be the same size. So we'll be able to do essentially 3 times 1/2 times the base times the height. The base, it looks like here, is 4. The height is 3.2. And these are not going to be super pleasant to do. I guess it could be worse. This is where my trick of dealing with the half early is helpful, in my opinion, because I can do half of 4, which is 2, and then 2 times 3.5, I can do in my head and get 7. So just throwing that out there. And on this one, I would do 1/2 of 4 again and get 2. 2 times 3.2 is 6.4. And then we need to times that by 3, which would be 2, carry your 1, 19.2. So what is 7 plus 19.2? 26.2 yards squared. This has been surface area of geometric solids. Hope you enjoyed the video. Please feel free to leave a thumbs up. Leave me a comment if you'd like. Make sure you subscribe to the channel, and I will see you in the next video. Bye.